Hello everyone, my name is John Challis and I'm from Concept Searching. And today I'm going to be talking about a thorny old problem in information retrieval related to precision and recall. Now, precision in information retrieval is when we retrieve documents that are all relevant to our search. And recall is when we can retrieve all of the documents relevant to our search. And in an ideal world, we would retrieve all documents and only relevant documents, achieving 100% precision and recall. But if we plot this on a graph, what we tend to find, obviously the ideal is to get our results up here with 100% precision and recall. But what we tend to find is a graph that looks more like this. And that's because if we're very restrictive about our selection criteria, let's say matching only words in a document title, then it's very easy to achieve high precision with all of the documents coming back being highly relevant. But such a restrictive approach is likely to damage recall, and a lot of relevant documents will be missed. To solve the problem, we loosen the criteria, we look for any word in any document that matches our search criteria, we achieve high recall, but we're likely to get much lower precision with some irrelevant documents coming in. And today I'm going to talk about how we can try to achieve high precision and high recall simultaneously. It turns out not to be a terribly easy problem. For example, consider this query: John Major, the UK Prime Minister. And suppose we came across a document with this text: Sir John Major served as the Prime Minister of the UK from 1990 to 1997. Well, it's got our major concepts. Clearly, this is a very relevant document to what we're looking for. However, consider the same search and a different document. John Prescott, a Labour minister, stated that the major spending on infrastructure in the UK was a prime example of Labour's policies. It's got all the right words, but any human would tell you this document is nowhere near as relevant as the first one. But most matching systems today, most search engines, will rank this document equally with the first document because it contains all of the search words. And this is because most search technology works on the basis of single words in isolation and doesn't take into account the importance of word ordering and word proximity, things that are so obviously important to the human brain. Of course, there are solutions, and the most obvious one is to use phrase searching. And with phrase searching, we put quotation marks around our key concepts, and we're able to drive up precision by restricting queries to those that match our exact phrases. But that's the problem. It tends to exclude any document that doesn't match the precise phrase, and as a result we improve precision at the cost of recall. Many relevant documents are likely to be missed. Exactly the same is true with Boolean expressions. You know, some lawyers, some information scientists are very comfortable using complex Boolean expressions, but most of us aren't. Most of us don't use Boolean expressions typically. But when we do, they tend to suffer from the same problem. They're too precise. They improve precision, but at the cost of recall. There are some other solutions around there. There's latent semantic indexing, probabilistic latent semantic analysis. There are also linguistic analysis techniques that have been used by some vendors. And I'm not going to talk about those today, although there is some information on those alternatives in my white paper, which I'll mention at the end of the talk. What I'm going to spend the rest of the talk talking about is concept searching. The only truly universal solution to this problem that works for the mass market by identifying meaningful multi-word concepts automatically. So let's take a look at something a little bit more complex. Let's say we're looking for information on insider dealing of shares by directors with access to unpublished, price-sensitive information. There's some nice multi-word concepts to get our teeth into. And any search engine that works on the basis of multi-word concepts is going to be able to extract these multiple words and do its matching on a higher order basis, delivering much higher precision with no loss of recall. And concept searching can do this using its compound term processing technology, because we're able to isolate and identify the multi-word concepts, and we look for these in addition to the single words in isolation. And when we find these words, these multi-word concepts, we're able to boost the ranking of documents containing them, thereby pushing them to the top of any match set or hit list. But even here we have some difficulties. Insider dealing might be referred to as insider trading. Shares might be referred to as company securities. Not all insiders are company directors, and so on. So even with this query, and even with concept identification, we can still find that we might miss relevant documents because they don't contain the right words or even the right multi-word concepts. But concept searching can help with this as well. Let's take a look briefly at all of the things we can do with compound term processing. It's not just for search, although obviously we can dramatically improve enterprise search with compound term processing. But we can also use the same technology to underpin auto-classification. This is the ability to identify what a document is about and tag it with metadata. And clearly, any process like that is going to benefit from higher order concept-based matching process. We can use it for search suggestion. And with our search suggestion, we can base it on all of the multi-word concepts that we found within an enterprise. And there's no need to rely on search history to drive our search suggestion mechanism within the corporation. We can use it for predictive coding applications. This is where we take one set of documents and then attempt to find other documents that would match the same collection, perhaps treating pre-classified documents as a training set. So for example, one example would be if we're trying to match an advertising feed to a particular user profile, then we can treat the documents and search queries and other activities of an individual user to identify what they're interested in. And then we could use predictive coding to find relevant adverts that would be interesting to that particular individual. That's just one example of predictive coding. Other examples exist in e-discovery and litigation support type environments where we need to do similar things. And finally, let's talk about query expansion. Query expansion is this idea that we might be able to return documents that are relevant to a particular query, even if that document doesn't contain the words that we're searching on. I gave some examples previously, but let's take another simple example. Suppose we do a search for laptops, and there's a document out there that talks about mobile computing devices. We'd like to return that document because it's probably relevant to our query. But with query expansion, we're able to identify concepts that are related to the query text, automatically include those in the matching process, and then potentially return documents that don't contain words in the original query. That's automated query expansion. And again, compound term processing will do this much more accurately than any approach that's based on single word analysis. That's all I really have time for today. My name is John Challis. I'm CEO and CTO at Concept Searching. This is my email address, johnc@conceptsearching.com. And if anybody would like to see my white paper, you can access it either via our website, or if you have any trouble locating it, please send me an email and I'll send you a copy of the white paper about compound term processing. Thank you for listening.